Welcome to the deep dive. So, if you're working with AI agents, especially ones powered by LLMs, you've probably hit this fundamental problem we all see. These models are amazing with language, right? But they kind of live in this text-only world. How do they actually do something in the real world, like book a flight or check inventory or, query a database reliably?
Yeah, that's the core issue.
Yeah.
They're disconnected.
Exactly. So today we're going to really dig into two key protocols trying to solve this. You've got the newer one, specifically built for AI, called Model Context Protocol, or MCP. And then there's the veteran Google Remote Procedure called gRPC. It's been around super fast, used everywhere in system architecture.
Right, and that contrast is what we really want to explore for you. It's not just about definitions. We need to understand the downstream effects, the architectural choices you make. Because you first have to get your head around the LLM's limits context window size, the fact its training data is static. These protocols are what let the agent become more of an orchestrator, figuring out what info it needs and when.
Okay, so it's kind of AI understanding versus raw speed.
In a nutshell, yeah. Do you prioritize the AI figuring out the why of a tool, or do you prioritize pure efficiency, like microsecond speed? That's the trade-off we need to unpack.
All right, let's start with that context window limit because it really drives everything else. We keep hearing about these massive windows, right? 200,000 tokens now.
Huge numbers, yeah.
Sounds like you could fit anything in there. But what does 200K tokens actually mean in practice?
Well, think of it less like a giant warehouse and maybe more like, I don't know, 100 pages of a really dense textbook.
Okay, so big for one chat, but not for...
Not for an entire customer database, definitely not. Or a massive code base, or like a real-time feed from a factory. You try to stuff all that in, the LLM just chokes. It's an information bottleneck.
Right. So the real solution isn't a bigger window necessarily. It's making the LLM smarter about asking for just what it needs from outside systems.
Exactly. It needs specific customer data. It calls the CRM tool, gets only that record, puts it in context, needs a stock quote, calls the finance API. It acts like a really good librarian, pulling just the right book right when needed.
Okay.
And needing these external tools immediately throws up this sort of philosophical difference between how we used to build things and how AI works. Traditional protocols, the kind gRPC was built for, they're deterministic. You call function X, you expect a result Y. Predictable.
Makes sense.
But LLMs, they're probabilistic. They're predicting the best next step. So they don't just need to know how to call a tool. They need the context, the what, the when, and really the why that tool is relevant for this specific situation.
Which leads us neatly to MCP, the Model Context Protocol. Anthropic put this out late 2024, and it feels like it was designed from the ground up with that probabilistic nature in mind.
Totally. It's AI native. MCP gives you three main building blocks, primitives, designed so LLMs can naturally map their language understanding onto what's out there. So you've got tools. These are the actual functions, like get the weather or run this database query.
Okay.
Then resources. This is the data the tools might need or describe, like database schemas, configuration files, things like that.
Right, like the structure of the data.
Exactly. And finally, prompts, which are basically templates to help guide how the AI should interact or phrase things.
And the absolute key thing here, the part that makes it AI native, is the descriptions, right?
Precisely. Everything, tools, resources, prompts, comes with natural language descriptions. The LLM doesn't just see get as orders V3.
It sees.
It sees something like, use this tool to get the last 5 orders for a customer, good for answering questions about recent purchases. The LLM can actually understand its purpose.
That's huge, especially for resources, I imagine, like if it understands the database schema.
Oh, absolutely massive.
Yeah.
Instead of guessing table or column names, which is super risky,
Yeah, hallucinations could be disastrous.
right, it can write accurate, targeted SQL that's safer, more reliable. It prevents the AI from just making stuff up about your data structure.
And this understanding is dynamic too because of the built-in discovery.
Yep. The agent connects to an MCP server, and it can literally ask, using commands like tools list, hey, what can you do?
And the server responds with those understandable descriptions. Use this weather tool only if the user mentions temperature.
Exactly. So the agent can learn about new tools or updated resources on the fly without needing any retraining. It just adapts.
Okay, now let's switch completely. Let's talk gRPC, the established player. Been the backbone for microservices for, what, almost a decade?
Pretty much. It's proven, it's fast, it's reliable, built for connecting tons of services in big distributed systems.
And its whole design philosophy is different. It's all about speed and efficiency.
Totally. It uses protocol buffers, proto-buffs, instead of text like JSON. So the messages are binary, much smaller, faster to serialize and parse.
And it runs over HTTP too, which gives it some superpowers we'll get to.
Right. But here's the catch. When you bring an LLM into the picture, gRPC, with its dot protofiles defining everything rigidly,
It gives you the structure.
it gives you perfect structural information, method names, data types, all that, but zero semantic context. It tells the LLM how to make the call, but nothing about the when or the why.
So the LLM might know a get weather function exists, but not that it should use that specific one when someone asks, is it cold outside?
Exactly. It lacks that probabilistic guidance, which means you, the developer, have to build something extra.
The adapter layer.
The adapter layer, or translation layer, whatever you want to call it. It's this piece of code that sits between the LLM and the gRPC client. Its job is to translate the LLM's fuzzy natural language intent, user wants their account balance, into the very specific, rigid gRPC call, like banking service, fetch balance for account ID.
Wait, couldn't they have just added like a good description field to the dot protofiles for gRPC? Why a whole new protocol like MCP?
That's a fair question, and it gets back to the core design. gRPC is scheme first, deterministic. You can add description, sure, but they're just comments, metadata hanging off a rigid structure. The LLM still fundamentally interacts with that rigid structure, so you still need that logic somewhere. The adapter to bridge the gap from the LLM's probabilistic reasoning to the specific function call. MCP builds that bridge right into the protocol itself.
And that adapter isn't just a one-time build cost, is it? It sounds like a maintenance nightmare.
Oh, it absolutely is. Think about agile development. Services change all the time. A parameter gets added, a method name changes, a data type is updated.
And every single time.
You have to go back and manually update the natural language mapping in your adapter layer. Otherwise, the LLM starts calling the wrong thing or it breaks. It becomes a huge drag, a source of technical debt.
Okay, so let's compare discovery head-to-head.
Right. MCP discovery is built down. Tool list, resource list. You get back descriptions tailored for the LLM. Call this financial tool when. gRPC has server reflection, which is great. It lets tools or developers see the available services and methods, the raw .proto definitions.
But no why?
No why. You get order history, but not the crucial use this for context.
Oh.
You're back to needing that manual adapter layer to provide the semantics. It tells you what's on the menu, but not what to order based on your craving.
All right, now let's talk speed, because this is where gRPC usually shines, right? The transport layer.
Absolutely. MCP uses JSON RPC 2.0. JSON is text. Human readable, great for LLMs to understand directly, but it's verbose. A simple request might be, say, 60, 70 bytes of text.
Whereas gRPC.
Protocol buffers.
Yeah.
Binary, much more compact. That same request might only be 20 bytes. Doesn't sound like much.
But multiply by millions or billions of requests.
And suddenly you're talking real savings in bandwidth, processing time, compute costs.
Yeah.
It adds up incredibly fast at scale.
And there's more to it than just message size with HTTP2.
Yes. Two huge things gRPC gets from running over HTTP2 that standard JSON RPC doesn't. Multiplexing and streaming.
Okay, break those down. Multiplexing.
Multiplexing means gRPC can send multiple requests and receive multiple responses over the same single connection at the same time without waiting for one to finish before starting the next.
Ah, so instead of request wait response,
You can fire off dozens of requests in parallel. Think opening 50 browser tabs versus loading one page at a time.
Yeah.
Massive throughput increase.
Got it. And streaming.
Streaming allows for a continuous flow of data in either direction or both. Essential for things like real-time stock tickers, live inventory updates, ongoing sensor data. MCP's request-response model isn't really built for that continuous flow.
So for a simple chatbot, maybe MCP is fine, but if you're building something high volume, production grade,
gRPC's performance becomes critical. Those saved milliseconds, the ability to handle thousands of concurrent requests, the streaming, that's the difference between a system that works under load and one that falls over.
Okay, so pulling this all together, it feels like we have this core tension. MCP is like, it was born for AI, focusing on that semantic understanding, the what and when.
Right, helping the agent orchestrate intelligently.
While gRPC brings the proven speed, the stale, the raw efficiency from traditional systems, but it needs that translation help to kind of speak AI.
Yeah, it's like choosing between, I don't know, an insightful philosopher and a high-speed courier.
Right.
One understands the message deeply, the other delivers any message incredibly fast.
So where does this leave us? What's the likely future here?
Well, the consensus seems to be emerging that you'll likely see both used probably together, strategically. MCP could become the standard front door for the AI, the discovery layer. The agent uses MCP to figure out what capabilities exist, when to use them, understand the resources, get the plan right.
And then for the actual heavy lifting.
For the high-volume calls, the actual execution, especially where latency is critical, it might then use gRPC as the underlying engine to make those calls as fast and efficiently as possible. Best of both worlds in a way.
That makes sense. Using each for its strength. Okay, so thinking about that potential dual future. Here's a final thought for you, our listener, to chew on. What happens if, hypothetically, future LLMs overcome the context window limitation? What if they could hold vastly more information? Does gRPC's raw speed advantage still matter as much if MCP makes the agent so much smarter and more targeted in what it asks for in the first place?
Yeah, does super efficient fetching matter if you rarely need to fetch things because the initial understanding is so good? It's an interesting question about where the real bottleneck will be.
Let us know what you think about that.
We've definitely covered a lot today, diving into two really crucial standards shaping how AI agents will interact with everything. What stood out most to you? Was it MCP's focus on understanding or gRPC's focus on sheer speed?
We genuinely want to hear your opinions, your experiences, maybe even your predictions. Drop them in the comments section below.
And hey, if you found this deep dive valuable,
Please take a second to hit that like button. It really helps us out.
and of course, subscribe to the channel, click the notification bell so you don't miss our next deep dive. Sharing this with colleagues or friends who might find it useful also helps us keep creating this content.
Thanks for joining us today.